Alright, welcome to task 4 out of 6 for intro to Pwntools. We'll be doing this task and it's called networking. Let's get straight into it. When you're ready to move on, please enter the networking directory. Inside you will find a note, an executable and more C code. In the last challenge, we manually inputted our exploit. Although Pwntools gives us the ability to send and receive data automatically, this can work both locally and over a networking port. For this challenge, we'll be using the networking tools, and in the next challenge, we will use the local tools. Unpacking the code. The note tells us what port is serving our flag. Please answer question 1. Okay, so let's look at the note. I am already in my directory. We can cat out the note. It says, "Dear Buzz, I'm running a service on port 1337, which has an overflow vulnerability. I've left you a version that will run on port 1336 so that you can develop your exploit. Sincerely, Dismas." So okay, let's answer question 1, and that is, what port is serving our challenge? That is 1337. Okay, if you netcat that port, it will say, "Give me dead beef," and prompt until the connection is closed. To test our exploit, we can run our own version on port 1336. We can use tmux or second SSH session to have two interfaces, one to run the service and one to develop our exploit. The code for this challenge is more involved than that of the previous challenge. I assume that's what you wanted to say. I've used the following code and edited it for my own purpose. For this challenge, we do not need to concern ourselves with main, but only the target function. Let us look at the target function. I already have that open. And this is the target function right here. He says that's our concern for this challenge. The struct at the beginning of the function calls targets, has two variables, buff and print flag. Struct is calling two variables, buff, which is a character buffer, and a volatile integer called print flag. The buff is a char array of size max. Max was defined to 32, and the print flag is a volatile int. These variables will be right next to each other in the stack. So if we manage to overflow the buff variable, then we can edit the print flag. If you see further down in the code, if the print flag variable is equal to dead beef in hex, then it will send the flag. Please answer question 2. So further down in the code, if our print flag is equal to dead beef in hex, then it's going to print thank you and the flag. Okay, we're supposed to answer question 2 now. Please use checksec on serve. Is there a stack canary? Okay, let us check. Checksec tac file equals serve test stack canary found. That's interesting. Networking to the flag. We'll need to write a script to connect to the port, receive the data, and send our payload. To connect to a port in Pwntools, use the remote function in the format of remote IP and then port. So we're importing everything from Pwn. We connect using the remote function, our IP, and then the port. We can receive data with either the receive bytes or receive line functions. The receive receives as many bytes as specified, while the receive line will receive data until there's a new line. Our code does not send a new line, so we'll have to use the receive in. In our test network C code, the give me dead beef is 18 bytes, so we'll receive 18 bytes. We have to send enough data to overflow the buff variable and write to the print flag. The buff is a 32 byte array, so we can write some character 32 times to overflow the buff, and then write our dead beef to print flag. So our payload is going to be 32 bytes and then print dead beef. We can send the payload with the send function, connect.send, sending our payload. To receive our flag, we can just use connect.receive in. Again, according to the C code, the flag will be 34 bytes long. So now we're going to be printing the flag. Run this against your server at 1336 and make sure it works. Once you have changed the port to the answer to question 1 to receive the flag. Okay, so let's get that working locally first. So I will just open my exploit. And so this is my local exploit. We're going to get this working locally first before we send it over to the networking port on 1337. And as it says in the note, 1336 is for local testing rather. So I will open half a tab here and I will get serve running. As you can see, it is listening locally, and we will run our exploit locally like that. And as you can see, it connected, opening connection to a port. It says give me dead beef, then it says thank you, and prints the flag. So this is not the actual flag. We have to now change the IP address and the port to send it to the network. And so let's move that way, put back our quote, change that to 1337, save that. We can exit out of this, we can clear this if I can type, and then we'll run our exploit. Hopefully it works, fingers crossed. There we go, we have our flag. Alright, that is it for networking. I'll catch you for task 5 shellcraft. Let's get it.